In question 5a, we're given the standard question of proving the sum to n terms of a geometric series. So in the first instance, we need to just remember what the sum to any number of terms is of a geometric series, which is given by a plus ar plus ar squared all the way up to ar n minus 2 plus ar n minus 1. The next stage is to actually multiply the sum through by r. So we have r Sn is equal to ar plus ar squared plus ar cubed all the way through to ar n minus 1 and ar to the power n. The next stage is to subtract those two lines away from each other. So we're left with Sn minus r Sn is equal to, well, we have a, and then if you notice, all these will actually cancel, leaving you with a as the first term and minus ar to the power n as the last term here. They're the only two things that actually remain. Everything else cancels. If we then look at factorising, we can see that we have common expression of sum to the number of terms here, 1 minus r is equal to, well, a is common here, a 1 minus r to the n. Dividing through, we can see we have Sn is equal to a 1 minus r to the n over 1 minus r, thus proving the sum to any number of terms. It also says that given that the modulus of r is less than 1, write down the sum to infinity of the series. Well, if r is actually less than 1 and we're looking for an infinite number of terms, if we just examine this sum to any number of terms, if we're talking about an infinite number of terms here, the only thing that's going to be affected is this here. Okay, remembering that r is less than 1, so it's effectively a decimal number, to the power of an infinite number would mean that this would actually tend towards 0. So this would become pretty much insignificant, leaving you with just s to infinity would be equal to, well, just a multiplied by 1 over 1 minus r, which is actually a over 1 minus r, the sum to infinity of a geometric series.